Good morning, doctor. I'm teaching in matrix number AE230061. Today I would like to present our analog electronics BEV10503 assignment with the topic BJT amplifier with high frequency. We are from section 2, group 2. And here is my team member with Chakekat AE230058, Chupali AE230073, Pezi Cheng AE230053, and me, Ting Sing E AE230061.
Okay, our project work is about the BJT amplifier. First, what is the BJT? BJT is the bipolar junction transistor. It's a 3-terminal device made of 2 PN junctions. It's used to amplify weak signal and as solid state switch. BJT function of the BJT is emitter based junction is forward bias and collector based junction is reverse bias. Then the second is amplifying frequency response. For the mid-range frequency have minimal interference for capacitor. As we know, frequency have lower frequency and higher frequency. In the lower frequency is about gain reduced by coupling and bypass capacitor. For the high frequency is gain reduced by straight capacitor. And the third is the common collector amplifier. The collector linked to the supply voltage and the emitter is grounded. Input at the base and the output from the collector. Higher input impedance and the lower output impedance. The bandwidth influenced by collector base capacitance and the load impedance. Neutralization to increase the bandwidth. And the last is the capacitor impacting frequency response. The higher value capacitor CB, CC, CE is affect low frequency response. For the low value of capacitor CBC, CBE, CCE, CWI, CWO, CMI, CMO is impact the high frequency response. In our question 1 is determine the RE and find the mid-band frequency voltage gain. First, we know the formula of the small RE is equal to 26 mV over IE. So we use the Thevenin theorem to find the RTH first. So the RTH is 40 kΩ parallel to 10 kΩ is 8 kΩ. And the VTH is 10 kΩ over 10K plus 40K times 20 equal to 4 watt. After we find the value of the RTH and the VTH, we use KVL in this circuit to find the IB value. So we assume that the current flow with clockwise direction at A, then we can know that IE minus 4 plus 8KIB plus VBE equal to 0. VBE is the voltage of the diode. So we using the formula of IE equal to beta plus 1 IB, and we can solve that and find the value of IB equal to 15.71 microampere. After that, we can find the RE value. RE equal to 26 mV over IE. Then we can find the value of RE is 16.38. After that, we separate the circuit to easy to calculate and simulate. So we want to find the ZI value. ZI equal to parallel R1 parallel to R2 parallel to beta RE plus 1K. So the value of Z1 is 2.359 kΩ. So if the R naught larger than or equal 10 RC, the R naught equal to infinity. So the Z naught equal to RC lah. So the Z naught and the RC equal to 4 kΩ. After that, we can find the value of AV. AV equal to V naught over Vi. So we can find that the value of AV is equal to negative 86.65 watt.
For question 2, it asks us to draw the low frequency AC equivalent circuit and determine the lower cut-off frequency FLE, FLC, and FLS, hence identify the low cut-off frequency of the system. This is the calculation for question 2, and at the above it is the low frequency AC equivalent circuit which we convert from the question given. Then after that we are finding the coupling capacitor CX using the circuit that we convert from the low frequency AC equivalent circuit. Then we need to find RL, which is parallel to the beta RE. Then we can get the value of RI is equal to 1359 and 62 ohms. After that we can find the value of FLS, which is using the formula 1/2 pi RS plus RI times CX. So we can get the value of FLC is 6.74 Hz. After that we need to use the pass-by capacitor CE as the circuit is drawn as below. We need to find the value of the RS inverse, which is RS is parallel to R1 and R2, and we can get the value of RS inverse is equal to 188.89 ohms. After that we need to find the value of RE, which is parallel to RS inverse over beta plus RE. Then we can get the value of RE is 24.95 ohms. After that we need to find the value of FLC, which using the formula 1/2 pi R naught plus RL times CC, which we can get that RO is equal to RC parallel to the R naught. Due to the R naught is infinity, so the R naught value is equal to the RC value, which is 4 kilo ohm. After that we can get the value of FLC is equal to 25.67 Hz. With the information that we find above, we can find the FLE, which using the formula 1/2 pi RE times CE, that we can get the value of FLE is 318.95 Hz. So the low cut frequency RL is equal to 318.95 Hz.
In our question 3 is sketch the low frequency response using the block plot. In y-axis is AV over AV, mean is dB, and the x-axis is frequency Hertz. For the x-axis, we calculate that the FLS equal to 6.74, FLC is 25.67, and the FLE is 318.95, and then this is our graph lah. Graph also proven by the LT SPI, and this is our simulation and design the circuit.
For question 4, we are asked to draw the high frequency AC equivalent circuit and determine the high cut-off frequency, hence and identify the high cut-off frequency of the system. From the calculation above, we can see that it is the circuit of the high frequency AC equivalent circuit which we convert from the question given. After that, we need to calculate for the high frequency cut-off input network, which is FHI, and we have to simplify the circuit so that we can find the value of CI, which is equal to CWI plus CBE plus C micro I. So the formula for the C micro I is equal to 1 minus AV times CBC. So that after that, we using the number given, that we can find the value of the CI is equal to 3.926 times 10 to the power of negative 10 farad. After that, we need to calculate the total resistance for the high frequency cut-off input network, which is RS is parallel to R1, parallel to R2, and parallel to beta RE, which we can get the value of the equivalent resistance is equal to 576.2 ohms. After that, we can using the information we find above to find the frequency of the cut-off input network, which is 1/2 pi RTHI times CI, which is we can get the value of 700.3.55 kilohertz. We need to find a high frequency cut-off output network with the simplified circuit below. So that after that, we need to find the value of C0, which is equal to CW0 plus CCE plus C micronaught. The formula for the C micronaught is equal to 1 minus 1 over AV times CF, which that after that we can get the value of the C0, which is 1.3046 times 10 to the power of negative 11 farad. After that, we need to find the total resistance for the high frequency cut-off output network, which is RC parallel to RL and parallel to R0, which we can get the value of 1.419 kilo ohms. After that, we can find the frequency for the output using the formula 1/2 pi resistance times C0, which we can get 8.597 megahertz. So the high cutoff frequency of this question is equal to 703.55 kilohertz.
Next, we sketch the high frequency response using the board plot technique. The vertical axis is AV over AV mid and the horizontal axis is frequency in the unit of hertz. From the calculation, the FHI value is 703.65 kHz and the FHO value is 8.597 MHz. After we connect all the points, we will obtain an exponential graph with decreasing slope as shown in the slide. The simulation result from LT-SPICE software also display the same graph shape similar to what we have drawn manually. Therefore, this also verified the graph shape that we have drawn. Next, this is the simulation circuit that we have designed for the high frequency response.
For the question 6, the question asks us to sketch the full frequency response of the amplifier for the low and high frequency region using the result of part 3 and part 5. So we just combine these two parts and the graph will become like this, the N shape.
For question 7, we are required to display the graph of the full response generated by the LT-SPICE software. And in this slide, this is the graph that we have obtained. As we compare it with the manually drawn graph in the slide before this, we can see that the shape and the amplitude of both graphs are the same, which verified the full response of the amplifier.
For the question 8, the question asks us to determine the bandwidth. So the formula of bandwidth is equal to high frequency minus low frequency. So 703.55 kilo minus 318.95 approximate to 703.23 kilohertz. In conclusion, in this project, we aim to investigate the lower and higher cutoff of frequency and plot a graph of the frequency response of the command emitter BJT amplifier. So our primary objective in this investigate was to analyze the behavior and performance of the amplifier circuit across a range of frequency. A simulation circuit of an assignment given was connected to make sure that both values obtained through simulation and manual calculation were the same. That's all. Thank you.